LOL. I appear to be on time this time for... Oh, I lied. I'm a minute late. Damn it. Okay, all good. Yeah. Yeah, this is day 75? Let's see, what did I put? Day 75, okay. Yeah, day 75 of studying compilers every day until I land a compiler role. Yeah, we're gonna keep tapping away at instruction selection. I did a lot of thinking about like how to implement this, and my conclusion is that this is just a mess. So I'm gonna need to like, I kind of just need to like build the plane as I fly it, I think. So yeah, we'll see what ends up happening. I think a good start is to, I guess, figure out where I was last time. Okay. So I guess I didn't really do a whole lot last time. Let me just like pull up a paint.net file so I can, I guess, talk about the general goals of, I guess, this sort of thing. Or I guess like the goals of the backend more broadly. So in one corner we have MIR, and then our goal is to get assembly out of it. If I can draw a box, okay. Yeah, so I guess the goals that the bridge between these two needs to accomplish is, there's a lot of stuff. I'm gonna like section it off in phases just because it like makes the most sense to me that way, but or at least like the way I plan on implementing it, I guess I should probably add LIR here. This is our IR for the backend here, and that will let us hopefully, I guess, represent the code in a more assembly-like fashion, and that will presumably make our life a lot easier. So going from MIR to LIR is the thing that we're currently concerned about. And what we need to do there is instruction selection. If I can write properly. Like the general idea of this is we have a very expressive and optimizer friendly MIR, and we need to get that more close to the assembly proper. So this is where I guess we have an explicit step for that. And then from here we can do a couple of things, and then eventually we want to like generate assembly if valid. So ASM gen if valid. If I can't write for the life of me with a mouse. Yeah, so then this is like kind of the very optimistic approach to I guess designing a backend, but we need to throw in a couple other things here. The first and most obvious will be register allocation, because we only have so many registers, and we have infinite variables, so we need to figure out one way to map them from one to another, and that is a problem that we need to worry about. Another one we need to worry about is scheduling. Because we want our instructions to run in, I guess, as optimal of a sequence as possible. Because we want our code to not be slow, so we want it to be CPU friendly, and that is what scheduling would do. And then the third concern that we have here is people optimization. And that is basically just like the small micro optimizations that exist. So like if you're writing to memory and then immediately reading from it again, then you can kind of skip that intermediate read, for instance. It's just like those sorts of small things that we would want to implement somewhere here. With that being said, these two are technically like quote unquote optional, but the only one that is like, I guess I should like star the ones that are like truly, or I guess I could star the ones that are optional. So scheduling is like kind of optional because we can still generate code, and then people optimization is also like kind of optional for a similar reason. we absolutely need to generate assembly, and we absolutely need to select instructions. So, and we also definitely need registers. So those are like the 3 strict requirements that we have. Regalok will also have to worry about things like register specific instructions, like shifts, for instance, is the big one, I think. And that will make a little bit of a mess, but we'll get there when we get there. We're still dealing with instruction selection. And then before this, there's like a couple other things we need to worry about just to like, we could technically put it in the backend, but I feel like it would be more useful if I were to just make them independent MIR passes. So I guess I'll just draw an arrow like this. The first one is, all right, let me just like put dashes in all of these real quick just to be clear. Yeah, so the first one here is, I guess, linearizing the IR, or at least getting it ready to be linearized. Because we don't want to like, because then we need to like figure out what is, I guess, how do I describe it? We don't want to have to like traverse the control flow graph, or like figure out which order to like paste things. We ideally want to have as few branch instructions as possible because those are like really expensive. So the plan is we can sort of sequence the basic blocks in a way that we have as many fall through blocks as possible. And then if we have a fall through block, we can just like, we can kind of just indicate it, and that will hopefully resolve a little bit of issue. Or maybe like do some sort of analysis with it. I'm not sure yet. What I did for fixed registers, insert some moves before regalok, and then use hinting to elide moves. Yeah, I guess that makes sense. I think the play is to I think we just add more edges to the interference graph and call it a day, I think. Because if or like the plan is to use graph coloring to, I guess, map registers. If something has to be, I forget if an edge represents if it is a valid mapping or an invalid mapping, but we can use that to represent a register specific operation. And I think that will be like the approach I try to take, but then I have to figure out what happens if we have like, if we make too much of a mess and we need to like spill everything. But yeah, I'll figure that out. That might be, I thought that would be in like a month time. At this point, it might be a bit more than a month time. We'll see what happens. Without extra moves, there's no solution at all sometimes? Yeah. Yeah, register allocation is hard. Yeah, that will be something that I think I just tackle as I approach the issue. Can we get into quant companies using Java? I think some might use Java. You'd have to double check though. I know most of them use like C++. Some of them use like C#. Yeah, it's just something that you'd have to like look up. I don't know off the top of my head. Let's go strategy. I did a bit of reading. I think I have some idea of how instruction selection will work. Also, real quick, one final thing I need to add here. We're gonna have a pass to linearize, or at least like rearrange the basic blocks in a way that makes it easier for us to linearize. And then the second thing is we want to like, I don't want to worry about arrays further down here, so we're just gonna like array to just like raw memory accesses or something like that, and I'll figure that out. I'll figure that out later. We don't have arrays yet, but once we do, we're gonna need to worry about that. So yeah, this is kind of like the overview of what the backend will overall accomplish. What's good, Johatsu? Good to see you. Is cracking the coding review book really worth the hype? I didn't find it that useful. I gave it a quick look, but your mileage may vary. I feel like the biggest utility of different books is just to like hear the same thing explained in a different way. So in that sense, it might be useful, but I don't think it's any better than like a lot of other resources that are out there. You can kind of just like pick whichever one resonates with you the most. Okay, so let's blow up this instruction selection pile. So let's just like draw an arrow here. So I mentioned like the general approach I want to take is tree tiling. And I think I kind of understand how I want to go about this, or at least like the steps I want to take for this. So like I'd want to, I guess I want to generate trees first, and then I want to merge trees, and then from there I can tile them. Generating trees is like a little bit messy because we kind of have straight line piles, so yeah, I guess we can just like list these out very vaguely and then figure out how to implement them. So generate like each tree per instruction, and then we can merge them. If I can spell. Yeah, we can merge trees, and then we want to tile trees. And then along the way, here's some other things we want to think about are like, what's a good color for this? This is readable. We want to like generate like physical registers for parameters. Like function parameters, or like just calling convention stuff. Yeah, I'm just gonna group this under like do calling convention. And that's gonna be annoying. But yeah, that's like kind of the overall goal for instruction selection. I think the thing that was confusing me last time was that I didn't have a way to like quote unquote generate the trees. So it was like, how do we get the trees? Do we already have trees? Do we not? Hopefully we can like generate trees in a way that like we can, I guess, do more reordering, and that will make the code more assembly like in theory. Update the script again and missed last stream since it was a family member's birthday. That is a very good reason to miss the stream, to be fair. Yeah, it's good to hear you're making progress. I made a whole lot of not progress because I stared at a book the whole time and didn't really get anywhere. Let me just like throw this diagram in Discord real quick because I'm going to forget that it exists. Speaking of which, you should join the Discord if you haven't. That's the best place to get notified when I go live and chat with the broader community. Everyone is really chill. And also I post some of this slush there as well. Okay, so I might have to bring up the book again, but I also might not. So we're gonna, I might just raw dog it and see what happens. Okay, so we have this like, MIR to LIR thing. I'm not really sure how I want to structure this though. This might be a little bit funky. Read the book out loud? Hell no. That sounds like something that would not be very fun for me. How do we generate the trees? I guess we could repurpose this visitor to be like a tree gen visitor. A tree gen visitor. And then we want like a tree merge visitor. We also want like a tree structure, I think. Yeah, so I guess like we can just like nuke some of this stuff for now, and we can figure out the specific shape of it later. So we want tree gen visitor, we want like a how do we merge trees? I guess how do you even generate trees? I guess we should have like a tree node class or something. Yeah, maybe I should make like a lower subdirectory. That might be like a reasonable way to do this. Or I could just fit everything in one file for now. think that's what I'll do. So we should probably put this on top so we don't have like, we don't have to like do an extra for declare. So we want class, I guess like tree node or something. That sounds silly. Let's do, I lied, we'll do it for now. We do tree node, and then we want like, I guess what types of operations do we have that we can work with? Let's look at our middle end language real quick. I guess we have like, I guess we could look at the examples. Want to know the most cursed thing I did today with the script? Tell me. Well, what could it can't possibly be worse than the stuff I usually do. Yes, the book is coming out again because I need to figure out what the hell is going on. Instruction section. Let's do single page again. Where's the page that I care about? Okay. So I guess we have like, we don't really have memory, so it's like kind of silly. We can kind of just use registers. Yeah, I think we'd also want like a immediate node as well, I guess, of some sort. We could probably just make those wrap the value types that we have, actually, and that might make things a little bit less awful. Actually no, I lied, that will make things more awful. Line breaks in PowerShell? Ooh, I mean... Oh wait, is that what semicolon does? I don't know, I'm assuming there's like a message I missed somewhere, but yeah. I love textbooks? Yeah, textbooks are great, honestly. I just haven't, I don't know, I haven't really gotten a chance to read a lot of them. I've been slowly trying to work through a couple though, so. You'll get to see that more once I finish up the backend, or at least get a working backend done to some degree. So boring it puts me to sleep. That's crazy work. 25 on discrete exam. I don't think you're cooked. There's a pretty good chance that like a lot of people also struggled with it because I think it's the first class that like, or at least like if it's in your computer science sequence, it's kind of the first exposure people have to like realizing that computer science is not just like writing code. There's a lot of math behind it. And I think that just like catches a lot of people off guard. Okay, so we want like op node. We want like, yeah, let's just like, we do node, we want op node, we want like, I guess, reg node, and then like, immediate node. Or something like that. We can like build up like this. Semicolon's a separator. I think that's fair. Like, you can kind of use like and to do that in bash scripts. That seems like pretty normal. What do we even do with call? Oh no. Does call get its own node? Probably does, right? Or is call where the boundaries lay? Compacting into one line is, I mean, like I do that a lot. I remember the starter code for like one of my classes was like, it was quite heinous. There was like an if-else if tree implemented just with ternary operators, which is easily one of the worst things I've seen. And then the only thing that made it worse was that right after that, so it was on an enum. So I was like, okay, yeah, maybe there's like some concrete reason to like not use a switch block. And then right after that, they use a switch block on it, and I'm like, okay, well, crap. So, yeah, yeah, that's kind of how the life is, I guess. It makes me cry a little bit, but I've definitely seen worse. I think we get rid of all the allocates, or maybe we should support them somehow. With allocate, load store, fee, I have no idea what to do with yet. I guess we can just make more nodes for now. We can do load node, store. Something like that? I don't know. And like, we could do a fee. A fee and then like, return, I guess. This is kind of funky. I dare you to turn all this into one line. That does not sound like something that interests me, for what it's worth. I guess call and return are kind of in the same pile here. I think fee we can kind of convert somehow. I'm not really sure how we would do that though. Huh, okay. I guess like, it's all like really annoying actually. It's like we could get rid of the allocate in some way, right? We could just like make this an alloc. Actually, no, this is fine. I demoted from admin? Damn, that sucks. Did you master DSA? Define master. I at least know what's going on. I'm hesitant to say that I'm very, very comfortable with it though. I think this is probably a good place to at least mark this for now. We can divide it like this, I think. Yeah, that's my work. Let's rename node to like tree. Right, yeah, because this generates the trees and then we can merge them and we can do something with tiles. Okay, let's start with this, I think. So register tree implements public tree. It's gonna be that. And then like, I guess this has like an MIR op in it, and then that like translates sort of one-to-one. I don't know, what assembly ops do we have? We should probably make like an assembly op thing somewhere. Alright, do we even need it? I don't think we do. I don't think we need it. Because we have like specific instructions for everything. So we need to like map these one-to-one somehow, I think. So I think we should implement these for now. And then Hmm. Well, what are we doing? Okay, I guess we could give this a shot. Register tree, this will have a... How do we represent instructions properly here? Maybe like straight line connections in some way? Somewhere? Yeah, we can do something like... I guess these templates are the ones we care about on the right side here. Or something like that. So then... how do we represent like loads? Oh man, this is really daunting. Okay, so we could do a straight line. We could use a straight line connection to represent a. Yeah, we could use that to represent a right, I guess. Yeah. Okay. So then. Maybe we just start with the standard tree and then just work through these, maybe? No, we can kind of just wishlist program this, I think. So I think that's what I'll try. I need to figure out how to like divide things, but I'll do that later. Okay, so we want tree gen visitor visit. Let's start with let's start with the binary op, I think. That will be the most straightforward, I think. Does this work? Okay. Okay, so we can do that, and then... What does this even look like? We want a... We also want a way to generate the operands. So if it's a literal, that's fine. If there's a value, we need to like load it, I think. Right? Oh no, we don't need to load. We kind of can just use the values, right? So then, what would this tree look like? Let's make a diagram. So let's start with like binary all. So we have like I. Oh, that's an ugly color. So we have like I equals A plus B. So we have I, and then so we have the I node, and this goes down to a plus node, and that has A and B, I guess. And then we have like things that generate those there. Okay, this seems kind of tenable actually. Yeah, on a straight line, I think we'll represent a right or something like that. We don't really have unary ops here, so that makes things a little bit easier. And then we can like people some other optimizations later, I guess. Okay, so we can do like. Okay, so we do just need the three things that we have here, which is pretty funny. Hello, I'm from Microsoft. We will hire you. Thank you. I will be looking forward to that one. Okay, so we're gonna call this a register, I guess. And then its only descendants will be like the source, I guess. Send us any credit digits, we'll get that sorted? Yeah, I bet, I got you. I guess we can copy this a couple times. We have immediate tree, and then we have op tree, I guess. And then we also probably want an enum to represent the different ops. Yeah, so we can do that like up here, maybe like we want enum. Or actually, we could use the MIR types, I think, actually. We should use the MIR types. Maybe also we just undo the rename to tree to node, because that makes more sense. Also this is wrong. This is still tree gen visitor. Which version of C++? I'm using 23 right now. Because I use a couple of ranges here and there that are, I guess, or I guess a couple of views that are included in 23. I also tried to use the print functions, and then it turns out that GitHub Actions really doesn't like it, so I stopped using those. Okay, so we have... What do we do here even? What am I doing? Okay, let's make a register node to represent the end, I guess. Footer, or I guess auto res equals unique pointer to register node, I guess. And then I guess we want like we want a way to, I guess, add descendants, or should we build it bottom up or something? I guess we can't really do it bottom up in a meaningful way, at least. I also think that the loads might end up being implicit. Loads and stores, maybe? What companies are you planning to? There's a lot of quant, a lot of big tech. That's kind of the path I've looked at. I guess maybe I should tile more of these trees. I have no idea how to do the call. Because we'd have to have a call node for that. And this is like a call. Oh, and then we can give it things here. So we can give it the params, and then we can give it like, I don't know, a function. Yeah, okay, we can do that. And then that's an assign. And the allocate, I don't even know how we're gonna represent the allocate, load, and store. I just joined the stream, could you explain the problem? Yeah, so currently our compiler is goes from C down to like an optimizer language. Right now my target is to go from that optimizer language down to assembly. So this is the whole range of things that we need to get done. All of the stuff in blue are like the different steps that we'd have to take. And then right now I'm focusing on the one that is circled in green, which is instruction selection, because we have this like higher end, more abstracted language, and then we need to turn that into something that resembles more assembly. So the problem is they don't map one-to-one onto each other, so we need to do a little bit of work to, I guess, fit around the edges with that. So the idea is we can like generate trees to represent each series of instructions. And then we can use those trees to, I guess, like match different tiles, and each tile represents an instruction. So then that allows us to, I guess, combine more simple instructions into more complex ones. And that is kind of how instruction selection is supposed to go. The problem is, since it's not one-to-one, I'm having a hard time figuring out how to even begin doing this translation. And it's causing a lot of problems for me. Yes, let's make a register node, and then we can do like register node. We want to like, or all of these should have like a mapping to like children or something. Or actually, that's not a private field. This is like stood, or we want like node putter source, I guess. We want to like have set source as well, I think. I kind of want to use structs for this, honestly. I'm quite tired of using classes and having to write getters and setters for everything. So we'd make that, we'd make the op node, and then that would take 2 arguments, a left and a right. And then we could generate those somehow. I guess like dynamic cast maybe might be the least awful way to do it. Because we have like a value type. And that will make things less awful. The other thing I'm scared of is like if it's just a straight up value, which is what we use for the function parameters, what we do. I guess each parameter would get its own tree. Or maybe we can add another node type, I don't know. Okay, well. Yeah, I guess we could start doing this like this. Maybe we just tile more trees? I don't know. I need to think about allocate, load, and store. I don't know how to handle those. The binary route makes sense to me. The call, I think, kind of makes sense to me. The allocate, load, and store are really where the problem arises for me. I don't know how to represent those. Maybe there's a hint here that would help me. Oh. Wait, these are just straight up things we can do, I think. Yeah, okay. We could actually just do it like that, I think. We can add like a read node and a write node, maybe. And then that will let us reuse things. And then we can add like... Actually, no, that would just be the same as load and store. So I guess we kind of had it correct to begin with. And then what do we even do with fee instructions? That will... that might make a mess. We might just have to make a copy. A copy of the predecessor. Or we could leave fees in it, maybe? I mean, let me look this up. Fee. What is this? Gitbook. Okay. Fee in the back end. I guess we could just implement those with a allocate for now, but that sounds really slow, so I really don't want to do that. Um, hmm. That might be what we have to do, I think. Maybe we look through the SSA book now? Restello. Maybe there's something useful here? In the destruction pile? We've looked through the construction a lot. Maybe there's something useful here. That's construction. Rename it destruction. Sparse representation of program information. We need to eliminate few functions. And transform SA code as conventional. Instruction is straightforward. Rename all few related variables into unique representative variable. Do you make any function for generating the outlier tree? That's something I'm working on right now. I guess that is like the thing, that is part of the process that I'm trying to complete right now. Also, hi Dad, I know you're watching the stream. Okay, let's turn on scrolling as well. This page thing is really annoying me. Scrolling, there we go. I should also pin that before I forget. What is conventional again? What is conventional SSA? I forget what that is. Rename all fee related variables, the source and destination operands of the same fee into unique variable. Okay, so we might have to do a fee destruction thing, which is really unhelpful. So we might need one more IR somewhere up here, actually. We might need like another box, like here maybe, before instruction selection. That goes into this. And this is like kind of like not LIR. I don't really know what to call this. Instruction selection happens here. This we need like SA destruction. So all fee related variables just need to share a variable, and then each fee function should have syntactically identical names for all of its operands. Oh, yeah. And then we can remove them because then the variables all share the name. Okay, and then fee related variables is a fee web. Conventional SSAs defines a flavor and da-da-da. If all variables of a fee web have non-overlapping live ranges, then the SSA form is conventional. Okay, so we might have to like, what do you even do here? We might have to like make, I was gonna say we're gonna have to make an instruction to replace fees, but that's literally just the fee instruction, so that wouldn't really be useful in any way. Union, you can do, yeah, union find, that would work. Going back to conventional SSA requires insertion of copies, okay, yeah. Split all critical edges, and then place fees by copies at the end of their direct predecessor basic blocks. Okay, that Yeah, okay, that seems reasonable. Critical edge is an edge for node, several direct successors to a node, several direct predecessors. It's an edge from a node that has successors. Oh, I see, okay. So we want to replace the edge with, oh, that's really messy. Several drawbacks. Specific architectural constraint, yeah, sure. Yeah, this is not easy for me to understand. So I'm not sure what's happening with the edge splitting, at least. I don't understand a lot of this code, to be honest. Property transformations? What? Okay. Chat, I might be cooked here. Okay. From where are you? I'm from the US. Maybe there's something in the cogen pile as well. Oh yeah, we can do it with like tree fragments, I guess. This way we can understand it, maybe. Can you link the book? I guess you have the title. It's titled SSA-based compiler design. You can look it up on your own as well. What is happening here? Okay, well this is difficult. List of instructions that are not necessary for the machine level, subsequent phases to remove copies. Okay, I'm like completely lost on what to do. This is also why I've been like trying to avoid doing the backend for a while, because it's just I don't know what to do. Which is really funny because I've done all of this once before for a class. And I've been avoiding trying to look at those slides because I want to like I guess get a different perspective on everything, but I might just have to look at the slides again. How do I handle fee instructions? It's really funky. That is where most of my trouble is coming from right now. Maybe I could just like preserve the fee somehow. Just make like a fee node, and then we can worry about that later, maybe. I guess we could just like eat that up in regalec. And that might be the way I handle it actually. I think I just maintain the fee instruction. This is so difficult. Okay, well, I guess we could work with what we have here. We have source here. I guess I can like rename things later. Immediate just has like a value, I guess. And then op node. I said register node. Yeah, a register node could have a null source as well, and that would be fine. Immediate node, I guess, has to have a value. Maybe we should also give these a name as well. I don't know. And then this we would have to give it like, we can steal the thing here from operator. Node star left, and then we can do right as well. And then we want middle and MR operate binary op. We have two different types of ops. Okay. You want to destroy the fee node or preserve it? Right now I'm thinking I preserve it, because then we can just like we can just propagate that information forward to register allocation, and that will, I guess, handle the process of destroying it for us. Yeah, and then like that will hopefully make things less awful. Yeah, this is all like, I'm just like building the plane as I fly it, so. Yeah, let's do that. Let's throw these in here. We want register node. Why don't you try making a visit function for your node? That doesn't help me right now because I need to be able to make the nodes right now. Just having a visitor won't help me because I don't have anything to visit yet. And eventually I plan on making some sort of a visitor, but that's gonna be like later once I actually have this more formally defined at least. Let me just like write out the list of steps that I want to go through here. So we want to generate trees, we want to merge trees, and then we want to tile trees. So maybe we want like a vector of tree or something like that. Or we need some sort of data structure to hold everything. After we tile the trees, then we can generate the program, I guess. Yeah, so I guess we could maybe try that as well. Maybe this will be easier if I like figure out the interface for this first. What is the compiler role? It's a position at a company where I can work on compilers and get paid for it. That'd be the dream at least. Okay, so generate trees. So we want a data structure to store these first, I think. I guess how would we want to merge them? There's like a well-defined algorithm for this, I think, somewhere. Compiler and tree tiling, I think. Maybe we could look in these slides? HFT? Oh yeah. Yeah, I've been applying to some of them, yeah. At least like some of them have positions where I can work on compilers, and I got pretty deep into the interview process for one of them recently, so we'll have to see what they end up saying. If I end up getting an offer from them, that might just be the shortest series that I could have ended up making, but I'll still do something with this channel at least. Do not fear. Okay, so then what is happening here? Okay, so oh wait, this is a little bit more readable. Whereas like instruction, selection, SSA. Is there maybe something useful in this paper? Oh, okay, wait. This might be... This is what the textbook was mentioning, not this one. Why not QuantDev? Because... So QuantDev in the sense that, like, I am working on a compiler, but I just think compilers are cool, and I want to work on them. It's as simple as that. Yeah. Working on, like, quant proper does not interest me as much as compilers do. And, like, you might have, like, some argument for why it is better, but like I just don't really have like a good rational like reasoning, I guess. It's just as simple as that. Oh wait, I'm already on the Rastello book. Whoops. Oh wait, this is the thing that we were just talking about before in this book, right? Instruction code selection. Okay. Maybe if I read through this, it'll be easier for me to figure out what is happening. Compilers too just have to start what you're doing? Yeah. I mean, there's no better way to start than to start, I guess, which I know says nothing, but like, yeah. I have to get access. I have to have access to this somehow. Let's see if there's a... Let's see if I have institutional access. Nope. Okay, unlucky. Okay, well... Okay, I'm just gonna look through these slides then, maybe. Or at least, like, look for a better place. Is this the same paper? This is the same paper. Okay, we can read through this then. Do you study CS? Yes. I'm currently a CS major. As opposed to CE or EE, I guess, to be clear. PBQP. I've heard of that term. I looked it up. I didn't understand it. Okay, so instruction selection exists. It is important. Standard techniques confined scope. Statements or basic blocks that you locally auto code. I might have to do that, honestly. New approach introduced. Whole functions in SSA form? Ooh. Disk optimization, da da da. Oh, wait, this is interesting. And then we see cost minimal. Okay, that makes sense. Incoming edges constitute arguments of an operation and are ordered. Outgoing edges denote transfer of the operation's result. So what even is an SSA graph actually? That might be very important to figure out actually. Maybe there's a section here that talks about it. Are you grad? So it's like kind of awkward because I am between my bachelor's and my master's right now. I'm finishing up my last quarter of my bachelor's and starting my master's at the same time. Is there an SSA graph somewhere that will be useful for me here? Like a definition somewhere? What is this? Oh, partial redundancy elimination. I see. I don't care about that right now. What is SSI? Only big data science courses? Fair enough, yeah. I mean, like, CS is just very broad, so yeah, it's very hard to like really pin down what the edges are because it kind of just blurs into a lot of different fields. SSA graph. Okay, found it. Okay, let's read through this section. I think this will be important to get context. It looks like today I have ended up turning the stream into another reading stream, but it is what it is. Okay, so represent some form of graph to support analysis and transformation. Many of these use SSA concepts, core principle, literal translation of SSA into graph form. Okay, I think that's probably the thing that I'm missing here actually. I think that will make everything way easier. Okay, control flow graph exists. We'll be introduced the core concept of SSA. CFG models control flow in a diagram. The graphs we will study instead model data flow. Okay, that makes sense. Maybe we make an SSA graph with like a visitor. Yeah, we know that SSA exists, so we can read through this. All the graphs are data flow graphs. So it is a directed graph where edges represent the flow of data from the result of one instruction to the input of another. Okay. Instruction executes once all of its input values have been computed. When instruction executes, it produces a new data value which is propagated to other connected instructions. And this imposes it. Whereas the CFG imposes the total ordering instructions, the DFG has no such concept. Okay. It's just models the flow of data. That makes sense. So it also needs a CFG to ensure correctness, but we can do a lot more things, but we need to keep both updated then. Midterm coming up and I don't know why I don't feel like studying. That's fair. I mean it's not fun to study. I had my midterms week like 2 weeks ago, and then last week was like midterm week part 2, and then I have like another midterm coming up this Wednesday, so it's just terrible. Yeah, I completely get it, but also like if you're not gonna study now, then like when are you gonna study later, right? So you may as well study while you have the time, is the way I approach it at least. An exam tomorrow in 6 hours? You should go to bed. Sleep is very important. I make a big deal about it to my friends, and then I proceed to not sleep a lot, but then my grades suffer, and then like equilibrium is restored. Yeah, you should try and get some sleep at least, or at least as much sleep as you think you need. Okay, so we should probably keep a data flow graph somewhere. That might be interesting. So the SSA graph. So we have SSA graph, we have program dependence graph, gaining fun. Yeah, okay. Yes. This is gonna be tough. The SSA graph is definitely something we want, so I'll definitely make a pass for that, I think. Maybe an analysis pass. to generate it. Okay, so we can construct it from a program in SSA form by explicitly adding def usestrings. I guess we kind of have this. It's kind of embedded in it, yeah. Now that I think about it. Yeah, wait, this works perfectly then. Okay, so we can kind of just traverse it in parallel then. Okay. Waiting for collab to finish? Yeah, fair enough. Say graph consists of vertices that represent instructions or phi functions. Oh, there's code in a figure. Okay. So there's the code and there's the SSA graph. Okay. Oh no. How do you stream on YouTube using OBS? Can you stream on both YouTube and Twitch at the same time? Yeah, there's a way to stream on both, but I also use Twitch for like some other things, and also Twitch just kind of sucks as a platform, so I want to keep things to YouTube as much as possible. Yeah, there's definitely a way if you're curious about it. When I stream to YouTube, I just directly use my stream key. But I think there's a way through like Stream Elements that lets you stream to both, or some other piece of software. I know multiple YouTubers do it, YouTubers/streamers. So there's definitely a way to do it, bottom line. I just don't want to manage both, I guess. And Twitch also just like, Twitch is just a terrible company, to be honest. Or sub-company. Subsidiary? Doesn't matter, Twitch sucks, so. Okay, what is happening in this SSA graph? So we have I3, an A, and this takes I1 and I2, so I1 is there. Okay, yeah, so this is just def use chains, I guess. Or use def chains. Some story I haven't heard. I think the big thing for me that like sticks out in my mind is just like this past TwitchCon. There's just like, or actually, every single TwitchCon. It feels like every single TwitchCon is just like a mess. They don't really care about their creators. It just seems like a rough platform to be on as a whole, and YouTube just feels a little bit more stable to me at least. I also want to do more like formally recorded content and like properly edited videos on YouTube. So I think it goes hand in hand pretty well in that aspect. Yeah. I think if I can like centralize most of my growth on YouTube, it'll be like a little bit easier to manage. Okay, so we know what the SSA graph looks like now, which is, in hindsight, it's a little bit obvious that this is what the SSA graph is. It's literally just like use def chains. So like we have uses and we have definitions. We go from the use of a variable to the definition of the variable, which, yeah, fair enough. What's good, Janine? Good to see you. How's it going on your end? Okay, let's go back to this paper. How old is this paper? This is 2008. Wow, not a lot has changed since then, it appears. I'm good. How are you? I'm also doing all right. Thanks for asking. Sure, so we have the SSA graph, yeah, okay. Nodes are simple operations including load stores, arithmetic operations, phi functions, and function calls. Okay. So this is just use def chains is what I'm getting from this. Let me zoom in. Saw slides of yours, are they from Carnegie, so are they open to the web, or do you need to be a student? Oh, like these ones? These ones I just Googled. You can definitely look these up. These are not my slides though, in any regard. This is not really useful for me because I don't think this talks about SSA, but this is like a pretty reasonable explanation for just like how this works with non-SSA IRs. I'm fairly sure. And it's also a lot more comprehensive than the slides that, or like the stuff that I'm familiar with at least. Just for the sake of time, and so I don't have to like, I guess, just so I don't have to like re-explain all that stuff from scratch, I'm gonna just like not explain it because I can't be bothered to. I'm a networking midterm and the slides I got are shit. Yeah, that's kind of how it is. My networking class, the prof was alright. I don't think the class was particularly amazing. The content felt kind of recycled, but yeah, you kind of just have to deal with it. Hopefully the textbook helps explain things in a different way that might make more sense. Version 7? Okay, sure. Strict patterns of trees, such that complex patterns with multiple inputs and multiple results cannot be matched. Interesting, okay. That's interesting. Okay, other examples instructions are RMW, okay. Oh yes, like these sorts of things. Then, sure, okay. Complex patterns are handled in tree-based approaches using a local people optimizer and post-processing step. Or express the program in the form of compiler intrinsics. Algorithm that is able to handle general graph patterns, the arbitrary cost functions. Okay, so then we do things. And motivation, the thing we care about I think is sections 3, 4, and 5, I think. The prof only uses the slides and doesn't use the book? Oh, yeah, that's tough. Are the lectures recorded then? Because if they are, then that might make things less awful. Oh, this paper is actually pretty reasonable. Okay, so then PBQP. Track assignment problem. Is there a better example of PBQP that's like less abstract for me? Or like a real world application? What even is PBQP? I should figure this out. Discrete variables and their finite domains. Sure. Solution is a function where domain, for each variable, choose an element in, okay. So it just needs to have a mapping. So you need to assign variable x to the element d. There's a local cost function. Assign to are the variables elements. And then another cost function. Matrix notation. Oh, I can't run from linalg. Rajallic? I guess that makes sense, yeah. I guess I've never heard it referred to as that. So then how does this relate to... how does this relate to instruction selection then? Okay, that makes sense. Go into tree patterns, okay. There's graph grammar. And tree patterns associate cost and semantic actions. Used to, okay. Cost middle cover. Grid grammar is normalized. Each rule is either a base rule or a chain rule. Base rule is a production of the form that that thing. So each of those are non-terminals, and op is a terminal symbol. Shouldn't this represent as a node? Okay, I see. Chain rules the production of the form that. Oh, okay. So chain is like a. Wait, what? That is very confusing. That's very confusingly written, but I guess it makes sense. We have 2 production rules. Okay, sure, fair enough. So then this is like, we can like nest an entire program into one line, sort of. Instruction selection problem for SSA graph is modeled this, so for each node in the SSA graph, we add a variable. Determine a variable is a subset of base rules with operations match the operation of the SSA node. The cost vector. It's cost of selecting a base rule. Imagine the graph represents data transfer. I guess that makes sense. I'm gonna need to read this multiple times, I feel like. I don't want to read this motivation section though. This is very dense. Which base rules and chain rules are too set? Okay, that makes sense. This instruction patterns have multiple results. Things that cannot be expressed in terms of tree-shaped productions. So then, figure 2 example. Is this do while what fucks it up, or? Oh, div mod. Huh. Div mod pattern shown in figure 4 can only be applied if the arguments for div and the mod node are identical. Expressed by naming the arguments of the div node with x and y. Cyclic data dependency. Yeah, that is what we care about here, I think. Or what I care about specifically. I don't really care about like architecture specific instructions for now. I think the big thing I'm worried about are like these cycles. And that causes a big problem. Memory dependencies. I'm concerned about prohibiting cycles in the selection patterns, considering memory dependencies. This is I'm so lost, I can't lie. This should not be as I feel like this should not be as difficult as it is for me right now. What does your normal day look like from when you get up? Usually I go to class and then I do work and then I come back and I eat and then stream. And then I like rest for the evening, usually. Main Senior algorithm for matching complex static patterns is algorithm 1. So identify instances of complex patterns within basic blocks. Transform the problem into PBQP. A solution for the PBQP instance using generic solver. Ah, this is such a mess. So what is a pattern? Like, what is a pattern here? I don't understand what a pattern is. Generalized production cover tuple instead of individualized nodes. Instance of complex correction. What's the question? What even is happening, I guess? I'm really struggling to read through this. Or like just visualize any of this. I kind of understand. I guess like what is a pattern? If there's like an example somewhere that they walk through, that might be helpful. Oh hell no. Okay, well this paper doesn't really help me at all. Okay, I guess we're just gonna have to... We're gonna have to figure something out here, I think. I think we might want to just like skip some instructions. Or at least like we want to figure out barriers for what we can tile. We could maybe do like a 2-pointers thing or something? Is it on Stack Overflow? Probably not. It's all very theoretical. I don't think Stack Overflow would really have anything helpful here. Or at least if it had anything, I imagine it would be on the first page already here. Yeah, this is not helpful. Yeah, a lot of this is rough. What does this article say? So destruction, regelock, and instruction selection. Wait, what? That seems like a strange order to... Okay, so something is wrong here. Something is definitely very wrong here. We have register allocation and then register allocation. Variables each fewer were non-interfering. Live ranges interfere, so it's not in. Oh wait, this is actually pretty useful. This seems like a more concrete explanation of what the book was saying. Inserting copies before each free function and introducing new names for the parameters. Removes interferences if they exist. Columns of the class of redundant variables and copies. Yeah, that makes sense. Nice papers from LLVM on how they do regelock. That makes sense. I'm not really looking at regelock right now. Instruction selection is like still the pile that I'm kind of trying to think about. Regelock, I think I have ideas on how to do. Original documentation of the compiler? What do you mean? Like I'm making my own compiler from scratch. There is no docs. Why does this do regelock before instruction selection? Oh, we make them up. Okay. Next post, okay. And okay, we don't have we don't have a next part. Use the C++ compiler docs as a reference? I guess that could work, yeah. LVM instruction selection. I've read about the selection DAG thing. So we convert it into DAG, nodes represent operations. Okay, yeah, so this is kind of, I guess that kind of makes sense. That was just the SSA graph. And then we can greedy match global cell. Overhead of creating a separate IR. Okay, maybe there's something useful here. Produce a selection DAG. Okay, also, I'm gonna turn Dark Reader on. Sorry about that one. There we go. Much more readable. Okay, so this multiply function. Okay, so we. This makes sense. What's good, Frothy? I haven't seen you in chat in a while, I think. I feel like I'm going loopy looking at all of this theory. Sequence of instructions without branch destinations, except the entry, no branch, except the, okay, yeah, basic block. This has multiple blocks. Oh, okay. Wow, okay. That does a lot of things. Okay, what do we even do with this? Change jobs, no longer working remotely? Aw, sucks. Well, I guess, are you enjoying it at least? No more React? Good stuff. If you're sending a link in chat, I can't read the link because it gets eaten by YouTube. So you'd have to send it in like Discord or something, maybe. Do you use Yak? No. I'm using, I think it was Pectool, yeah. I'm using Pectool to, I guess, generate the parser, but everything else is by hand. Selection DAG. Sure, so we have this, selection DAG goes there. What are you reading about? So right now I've finally decided to start the back end. And right now I'm worrying about instruction selection, so I need to figure out how to do that. I've spent like 2 streams not knowing how to do it, anything there, and this is now the 3rd stream that I don't really know what's happening. So I'm like slowly figuring out what's happening, but it is like very, very confusing, at least. Source code artisan website? Huh? Oh, I see. Oh, it's literally this one. Yeah, this is the site I'm on already, I think. Or at least I was like looking at that. I don't think this was helpful from here though. So I guess I'll just look through these slides maybe. There might be something helpful here. Are there pre-required things for the compiler? There's like a big screenshot somewhere in my Discord, but you pretty much need to like go from a source you need to like do a lot of things to the source language to turn it into like a optimizer language. Then you can run some optimizations on it, and then you need to like turn it into assembly from there. Is this an LLVM thing? Yes, I'm looking at this so I can like maybe figure out how I want to implement it myself. So we have DAG combiner. What is happening? Each DAG represents a basic block. Okay. Then, yeah, I'm getting very lost right now, I can't lie. So you have types, more types. Opcodes, and then other fields. Oh, SD node. Okay. Okay, so I think this is a better explanation on like what is even happening in here, I think. How'd you come up with Golf 1? I thought I was good at golf, and then it turns out I was not, but the username still stuck because I didn't want to change it. Funnily enough, I don't play golf anymore, I play tennis. Then SD value, the 5 and the type. Oh, and then uses are the edges. Okay. So add, we have. Okay, this kind of makes sense, I think. So this is join. Block. Oh, I see. Is MVC again? Machine value type, okay. Are we at a point where LLVM docs don't exist? I fear we might be. Or at least the docs are unwieldy enough to the point where I don't think I can really understand what's happening in them. So each node has an opcode, 1 or more results, and then 0 or more operands. That makes sense, I guess. So then these registers live in other blocks. That will cause a problem. Oh, copy from reg. Okay, I see. Okay, so that I think that is the solution to my big question, actually. We can also use, like, we can use this to represent fees as well, right? Entry token. Oh, okay. This branch is scheduled after the rest of the block. We want... Okay, yeah, that makes sense then. Oh, okay. I see this is where the mess is coming from, at least. Loads and stores, we can chain token factor. Huh, okay. So first we build it, it's just one-to-one, that makes sense. We can kind of just do that. Struct operations are lowered element-wise. Oh, interesting. So we have our own calling convention thing here. Legalization, that's fair. And then we can... What is happening? What actually is happening? Every type in action. Oh, okay. This is all under legalization. This I don't really care about yet. MVT glue is really funny to me. Okay, we mask off the high bits. That makes sense. It's really interesting. Instruct selection dialog on how to legalize a vector type. Okay. Operation legalization. This does a lot of other stuff. Well, cursor, hell no. Anything but that. Okay, a lot of this stuff I don't think I need. This is all stuff I need to like learn about eventually, but yeah. We definitely need more like people optimization stuff. Okay, so that all makes sense. And then instruction selection. This is a thing. Nice, most generic SD nodes with machine nodes. Interesting. Table gen generates all matching code. Ah, this is not fun. Topological order, bottom up, prioritizing heuristics. Okay, scheduling we don't really care about yet. Okay, well, so I guess what I've learned from this is we're kind of just doing what I already planned on doing, which is fortunate and unfortunate at the same time. It's fortunate in the sense that I know that this is like a solid plan. It's unfortunate in the sense that I still have no idea how to go about doing it. And I don't think looking through the source code is something I would particularly enjoy doing right now. So maybe we'll just like draw a skeleton for this and call it a day. What do we even do here? So let's, I guess, how do we even generate the tree? We can kind of just like, we can just plonk things down per basic block, right? Yeah, and then call gets an instruction, so that will handle itself, I think. Yeah, okay. So we can kind of just like set the scope of each of these to basic blocks, I think. Just like per basic block. I guess like make all the atomic trees per basic block. Barrier will just be between basic blocks. Add, make sure to add a node for what was it called? There's a thing in the slides. How does it handle lows and stores again? Okay, well, yeah, it's this copy to and copy from reg thing. Yeah, so we want copy to reg and copy from reg. I think those are the big things that we're missing. And then I think that's the big thing. What do we do with fees? Does this break the fees? Or like selection dag LVM, or maybe there's like an example somewhere here. That's not really helpful. Okay, maybe there's something here. To be written, okay. Okay, so we're not gonna look at that then. Regalloc. Instruction section. So where does this handle fees? Let's just look up fee. Is this the right section? Oh wait, we just keep fees through it. Okay. Well, that's nice then. Okay, so then we can, or I guess we could preserve fees. And then we can, yeah, okay, so then we can just break them at the, We can break them when we allocate registers, I think. Right, so let's just like do all of these. Get rid of that. And yeah, so we can do that. Merge trees, I think we will figure out as we go. That shouldn't be that bad, I think. We can just like, it's just like data structure remanipulation, I guess. It shouldn't be that bad. Tiling trees will be fun. I think that's pretty standard. And then the final cleanup, we just make the program. Could you show the current progress? I mean, there's not really much to show, I think. We just have like a more complex parser now is the big thing. Yeah, we do a bunch of other messy stuff here now with the expressions. Since you've last checked, at least. I think it's most visible in the test case set that we have now. If we go to input and then like op, I think? Yeah. So these are like pretty standard, but we support like things that, we support like real expressions now instead of the terrible, what's it called? Instead of having like one operation per line, we can do like compound things now. Yeah, that's like the big change. All the code's on GitHub if you want to take a look. But yeah, let's just commit everything. Some sort of slush, none of this works. It was just a reading day after all. I need to format it, okay. Yippee. Okay. I think that's what I'm going to call today's stream. I still need to do a lot more thinking and a lot more planning. I might do a little bit of scaffolding off stream just so like, just so it's a little bit less uninteresting. Let me just fix my camera. Okay, cool. Yeah, thank y'all for showing up to the stream. I think I have a better idea of what's going on, but I don't quite know what's going on yet. So I will still do more work off stream. Once again, I appreciate y'all for showing up. Make sure to sub to the channel if you haven't and like the stream. While you're down there, join the Discord to stay up to date with what I'm doing and get pinged when I go live. And you also get to see this terrible diagram that I drew today. Yeah, aside from that, connect with me on LinkedIn, add me on GitHub to stay up to date with what I'm doing. Yeah, I am in fact gonna go touch grass now. So yeah, take care y'all, take it easy, and have a wonderful rest of your day wherever you are.